look at the top
Mm-hmm.
and the bottom separately, and you say, well, what happens is 2x cubed minus 5x goes to infinity. 3x cubed plus 6, it also goes to infinity. So this thing, infinity over infinity, is called indeterminate form.
Okay.
Right. So this indeterminate form is bad, for lack of a better word. And
Okay.
what you have to do is end up taking the derivative of the top and on the bottom. So when you take the derivative of the top, you get 6x squared minus 5. On the bottom, 9x squared, like this.
Okay.
And you do the same thing. It's kind of rinse and repeat. If it works, so it goes to infinity over infinity again.
Okay. Are
So
you
again,
seeing this from a graph?
no.
Oh,
Well, kind of, yeah. I mean, you're supposed to know that x to the n always goes to infinity
okay.
or negative infinity. So if you're asking, yeah, like 6x squared minus 5 looks like this, and so it goes to
Oh,
infinity.
right. Okay.
And with 9x squared. So you take yet another derivative, 12x over 18x. Now this time you can make some cancellations. You're allowed to actually do the algebra or do the math.
Okay.
So it's really 2 over 3.
Mm-hmm.
And this is where it's like you're going way back to the early parts of the course when it's just a number, that is the answer.
Okay.
Questions on that? Thoughts?
No, that makes sense. Yeah.
Okay, there's a couple of other types of indeterminate forms. This one here, 3 sine 0 minus 3 times 0 over 0 cubed is 0 over 0. So that's another indeterminate form. One of them is infinity over infinity. This one is 0 over 0. So you do the same thing. You take a derivative of the top and a derivative of the bottom. So the derivative of 3 sine x is 3 cosine x minus 3 over 3x squared, like that. And then you do the same thing. You put whatever the thing is in there again.
Okay.
So again, you put 0 in. 3 cosine 0 minus 3. Cosine of 0 is 1. 3 times 0 squared is 0. So again, you get 0 over 0, which is again indeterminate form. So in this indeterminate form, you have to get another. So let me write this here. You just keep taking derivatives. So derivative of the top, 3 cosine x, derivative of cosine is minus sine, so minus 3 sine x over 6x. And so you try 0 again.
Okay.
Like using that fake ID, you just keep trying, right? Hopefully they'll let you get in.
Yeah. Very
Kidding.
true.
I don't know anything about that. All right, 6 times 0 is 0, sine of 0 is 0. So you again get 0 for 0.
Okay.
You might be losing hope here, but you hit that last place on 4th Avenue and they tell you, come on down,
Yeah.
and now it finally works. You can finally put 0 in and get a number. That is not 0 over 0. 3 cosine 0 for 6 is minus 1/2. So there's kind of a shortcut to doing these problems, kind of. Let me grab that. And I think you said your exams are on multiple choice.
Yeah, they're all multiple
You
choice.
you could pick a number really close to 0, like 0.0001 or something, or how many zeros you want.
Mhm.
And when you put that in for X in your calculator, you'll get really close to our answer, -1/2. It'll be minus 0.4999999. And maybe one of the multiple choice answers is -1/2. And you
Mhm.
recognize that and go on from there. So you
Yeah.
don't have to do this, but that this is the, the correct way to do it, if you will.
Okay.
All right, so next problem here, number 3. You have to be able to put pi over 2 in here. So I don't know how much of your trig you remember. If you have a calculator, you can just make sure your mode is in radians when you're using the pi's. Do you want to verify what the indeterminate form here is for me? Be good
Yeah.
for you to try that in your calculator.
Make sure it's in radians. Yeah. Okay. Is it still 0/0?
It is. It should be 0/0.
Yeah, okay.
So now it's about taking a derivative. So like when you look at just the top, 3 minus 3 sine theta. So what is the derivative of 3?
It's 1.
0,
Yeah, 0.
0. The constant -3 goes with the sign. So like what's the derivative of sine? Do you remember from?
Cosine.
Oh, and by the
Negative.
way, did you get it's just cosine. Did you get a reference sheet on your exam? Like, did you bring in anything?
No, she told me we weren't allowed to.
Oh, that's
Yeah.
rough. That is rough. All
Yeah.
right, so then the bottom here, 2 plus 2 cosine 2 theta. This one's a little bit more involved. The derivative of 2 is 0.
Mm-hmm.
Derivative of cosine is minus sine. So it's -2 sine 2 theta, but then chain rule of the inside function. What's the derivative of 2 theta
Um,
or 2x? What's the derivative of 2x?
oh, it would just be 2.
Just be 2, yeah. So you're in this part of the course where you're going back and forth between derivatives and integrals. It's really tough to remember. So again, you have to, I'm just simplifying here.
Okay.
You have to try pi over 2. So grab your calculator and calculate these. And it's not enough to just do like the top one. You really have to do both because the top one is 0 and the bottom one is not. That's okay because then it's 0.
Mm-hmm.
So if you're only going to do one, you're better off doing the bottom one, truthfully.
Okay. It's still 0/0 is what I got.
So unfortunately, you gotta take another derivative. So derivative cosine is minus sine, so it becomes 3 sine theta. On the bottom, the derivative of sine is cosine. It's -4 cosine 2 theta. But then the chain rule again, always have the chain rule when you have an inside function and you multiply by 2. All right, so again, you're back to trying to put pi over 2 in for theta and see what you come up with.
I got 3/8.
And that's correct. So there's nothing difficult about any of the individual steps, like putting the number in, taking a derivative of the top, taking a derivative of the bottom. It's just the over and over again. You got to do it over and over again until you get down to what you want. So, all right, number 4. Go ahead.
I said I wish there was an easier way.
Like I said, you could just put a number in really, really close to pi over 2.
Mm-hmm.
So, you go to pi over 2 in your calculator and it's 1.57, whatever, and you put something really, really close to that. You put it in for theta and you look for the answer that's closer to it. That's your shortcut. So actually, why don't we try that in this one?
Okay.
So picking a number really, really close to 0 from the right, that means it's a little bit right of 0. Like I don't know, like 0.00001. Okay.
Okay.
Why don't you try that in here and see what you come up with?
Where is LN? Oh, never mind. I found it. I'm sorry. I got 0.84948. Crazy number. Should I turn it into a fraction?
You have to get the whole thing. Like you've got to put both the top and the bottom in your calculator. So natural log of whatever you're doing squared plus 4 times 0.00001, whatever you chose, over natural log of 0.00001. Like that. You have to get the whole thing.
I think I did. Is that wrong? Hold on. Oh, I got 84.83.
This is the issue with doing this approach. Something isn't quite right. Like maybe you didn't put the right number in. So should be a parentheses there. I'm sorry, no. I guess no, that's not that. So that's where you gotta be really, really careful of this approach. So that is definitely not. I mean, most of the answers are gonna be like at the fraction space or so that's the risk here. Let me try this also. All right, natural log. Okay, I'm sorry. You did say 0.8795, or you said 87 point.
84.83.
Okay. So let's just do this the traditional way.
Okay.
So we got to take a derivative of the top. Derivative of the top is 1 over 2x plus 4x. Sorry, that's not right. It is 1 over the inside function, x squared plus 4x times the derivative of the inside function of the bottom function, which is 2x plus 4, like that. The bottom's derivative is 1 over x. Is that okay or not?
Yeah, yeah.
Okay, now you do want to do a bit of simplifying here. So you're going to multiply the top and the bottom by x, or x over 1. So it clears on the bottom, like all this goes away. On the top, it ends up being 2x squared plus 4x over x squared plus 4x, like this. You agree with that?
Yes.
Okay. So um, the next thing here is to take the limit as x approaches 0 from the right, 2x squared plus 4x over x squared plus 4x. When you put 0 in, you get 2 times 0 squared plus 4 times 0, which is 0. 0 squared plus 4 times 0, which is 0. You get this indeterminate form again. So you again have to put in, you have to take a derivative. So the derivative of the top is 4x plus 4. Derivative of the bottom is 2x plus 4. And then you put 0 in. Limit as x approaches 0 from the right.
Mm-hmm.
So this time though, when you put 0 in, it's 4 times 0 plus 4 over 2 times 0 plus 4, which becomes 4 over 4, which equals 1. Now the
Yes.
problem with your answer, when you said like 0.87 or,
Mm-hmm.
it's not close enough to the correct answer. Like you have to go way, way out to get it. Meaning like you need a number even smaller than 0.001.
Yeah.
So that's the risk. The risk is like, would you see that? That's the,
Mm-hmm.
not sure.
Yeah.
All right, I'm gonna step away for 30 seconds, grab some water. I'll be right back. We'll keep going.
Okay.
Okay, let's move on to number 5. Again, if you ever want me to just move faster, you're always welcome to tell me to move faster.
Okay.
Um, all right, so use L'Hopital's rule to find the limit. So that if you were to graph the top and you were to graph the bottom, they both go to infinity.
Okay.
And you'll just get in the habit of when you're just going to start taking derivatives. So the derivative of e to the 5t, the e to the 5t is itself. It's e to the 5t, but then you have to take the derivative of the inside function, which is 5t. So you multiply by 5. What is the derivative of t squared?
2t.
2t. On the bottom here, derivative of 4e to the 5t. It's always itself.
Okay.
And then you multiply by the derivative of the inside function, which is 5t. So you multiply by 5. And then the derivative of minus t, what would that be?
Just -1, right?
-1. Good. Yeah. And so this has the same problem as the previous one. It goes to infinity over infinity.
Okay.
All right. So you got to take yet another derivative. So let me just clean it up here. I do want you to try taking the derivative this time
Okay.
of the top and the bottom. I'm just going to rewrite it here. So that's a little nicer. But yeah, go ahead and give that a try. Let me know if you have any questions.
would it be 25 e to the 5t plus 2 over 40 e to the 5t?
Sorry about that. Sorry about that. That's not good. So again, unfortunately, again, it goes to infinity over infinity. So I guess what you have to do one more time.
Derivative.
Yeah.
I got 625 e 5t to the 5t over 1600 e 5 to the 5t.
Where's the 1600 coming from?
40 times 40, right?
So I think I didn't get the correct. This one should have been 100. The because it's 20 times the 5.
Oh,
And that
okay.
should be 500 e to the 5t.
Okay.
So now the e's cancel and you're just left with the number.
Okay. Oh, so it's 625 over 500.
Yeah, and then you want to divide and reduce that. So you're welcome to use the calculator. If you're using a TID3, you know, you can do the two fraction, the math. Enter.
Would it be 5 over 4, right?
Yes. Right. So I know it's a lot, but I mean, hopefully you're getting the feel for how to do these.
Yeah.
Are these all L'Hopital's rule?
I think some of them are different, but
Yeah. Um, all right, so let's look at number 6. But sometimes you have to do a rewrite step before you can do the problem. You've seen that a lot in calculus here. The rewrite step, because L'Hopital's rule is almost always for like fractions. So in this case, it'd be like 5 e to the x over x squared. And if
okay.
you're wondering about that, x to the -2 becomes 1 over x squared. So the limit as x goes to infinity is infinity over infinity. Okay, so the first derivative is 5 e to the x over 2x. Same problem. It's infinity over infinity.
Okay.
All right, and then from here you take yet another derivative. 5 e to the x over 2. And this time it's not infinity over infinity. It is infinity on top, but it's just 2 on the bottom. So basically it's just asking, like, what does the graph of e to the 5x do? Well, it goes up like that. And so this goes to infinity. So that is your final answer.
Okay.
So you could graph this to try to figure it out. Like you're asking for like some shortcuts. You can always graph it. You just got to know, you got to hope that you go out far enough that you can see the end behavior. You can also try numbers and see if they get bigger and bigger and bigger.
Okay.
Any questions or thoughts on that?
No.
Okay. Let's look at number 7. There's a bit of explanation needed to this. So the idea here is that you'd say, okay, y is really 6x to the 7x.
Okay.
They're like, why would you do that? Well, if you can't, we don't have any way to do this as is.
Okay.
So and then you're like, okay, well, let's take the natural log of y, like we were doing. I think we did this in a previous lesson. Natural log of 6x, actually, so it's actually natural log. Oops. Like that. And the 7x can come out in front. So it becomes natural log of y equals 7x, natural log of 6x. And now we can take a derivative. So the derivative is well, how do I want to say this? I'm trying to think about how to do this. So that because I'm probably gonna make this more complicated. Let me
Mhm.
have you try this again. Try putting in 0.0001 in for x. So it'd be 6 times the 0.0001 to the power of 7 times 0.0001, like that. And I'll do the same. Let me look, because the explanation I gave here isn't going to be ideal. This will be a little better.
0.9948.
Yeah. So what is that really close to?
1.
Yeah. And you may want to just remember that for the style of problem
Mhm.
rather than trying to, because what I'm about to do is not going to be very clear. So I'm going to shy away from that for the moment.
Yeah.
All right, but let's keep going here. All right, so we're on to some different style of problems. I think these are the most difficult. These are your optimization problems. There's a few shortcuts, but try to address those after this. So it says find the smallest perimeter and the dimensions for a rectangle with an area of 196 inches square. So here's your rectangle. And we're going to use X and Y. You typically want to use X and Y, just like we've been doing the whole course. And the area, which is X times Y, is 196. 196 equals X times Y. Okay.
Okay.
Now we're interested in the perimeter. The perimeter is 2x plus 2y. Is that okay?
Mhm.
So the perimeter is 2x plus 2y. We can solve this equation for x or y. Typically you solve it for y. And the reason is because we're just more used to doing everything in terms of x. So when you solve for y is 196 over x, and put that in here, your perimeter is 2 times 196 over x, like that.
Okay.
because y is 196 over x. So now you take a derivative. So could you take the derivative of this for us, please?
Yeah. Would it be 2 plus 392 x to the, is it -1 or -2?
So the rewrite here is it's 392x to the -1. So what
Okay,
does the
yeah.
power rule tell you in that case?
You multiply that by 1. So it would be to the 3, it would be negative, hold on, sorry. I have it like all written down. 2 minus 392x to the -2.
Yeah, minus 392 over x squared.
Okay.
All right, so now you set this equal to 0.
Okay.
And so you solve for x. So this is 2 equals 392 over x squared. Multiply both sides by x squared,
Okay.
which leaves you 2x squared equals 392. Divide by 2. So you got x squared equals 196. Take a square root of both sides. X equals 16. So the value of x here is 16.
Okay.
To find y, you've got to go back to an equation with y in it, which is this one right here. 196 divided by 16 is 16.
Okay.
And it is very common that the answer is a square for this style of question.
Okay.
So keep that in mind. Like you don't actually have to do any calculus, but the calculus supports the answer. So the smallest perimeter, the perimeter is a walk around. If you walk all the way around this, what would the perimeter be?
It's 32. I'm sorry. 32. Yeah,
That's only going halfway around. You got to go keep going.
32 plus 32 is
Yes,
4. Yeah.
we're good. Good. The dimensions of this rectangle are 16, 16. Any questions on that before we move on?
No.
All right, we're gonna do 10 next because it's more like have some similarities here.
Mm-hmm.
All right, a rectangular plot of farmland will be bounded by on one side by a river, and on the other 3 sides by a single strand electric fence. So typically that's the river. And you got this X, Y, and Y like that. It's a good idea to remember the picture like this. You can draw it other ways, but this is the best way
Okay.
typically. So you have 600 meters of wire at your disposal. That's for the 3 sides. So you've got X plus 2Y equals 600. All right. And then we want to maximize the area. Okay, so the area of this is X times Y. And that's where we use this other equation. We solve it for Y.
Okay.
So could you solve this for Y, please?
Okay.
On the right, tell me what you come up with.
I got y equals 600 minus x over 2.
Okay, and your choice if you want to like further simplify that. do like 300 minus 1/2 x.
Okay.
Okay. So now our area equation is x times 300 minus 1/2 x, or 300x minus 1/2 x squared. Will you take a derivative of this, please?
Yes. Would it be 300 minus minus 1x?
You set that equal to 0, so what should x equal?
It should, wouldn't it be 300? Negative 300.
Well, I mean, be careful with how you answer that because x is a length,
Yeah.
so it can never be negative. Now,
Yeah.
how does 300 relate to the original number they give you in the problem?
600 by 600 meters of disposal, the largest area.
I'm just the numbers. How is 600 related to 300?
Oh, it's double of
Okay,
300.
now it's
Sorry,
always double.
what?
It's always double in this problem, or it's always half, depending how you look at it.
Mhm.
So now y, give me the value of y based on this equation over here.
Say that again?
What is the value of y based on this equation over here?
Oh, 600 minus x over 2.
Okay, and do you know the value of x?
So yes, 300.
Okay,
I'm
okay, so
joking.
give me the value of y, please.
Oh, 300 divided by 250.
Now, it is always the case in this problem that the other dimension is half of this dimension. So you don't actually
Oh,
have to do any of the calculus if you remember this.
yeah, that's really
Okay.
nice.
It is, and that's I want you to be able to pass this class. So the
Yeah.
shorter side is 150 meters, the longer side is 300 meters. You can remember this. You can remember how these are figured out here.
Yes.
This is for the one with the water. It's not the same as the one that's the one we just did. The one we just did is square, it's different.
Yes. Yeah.
The area is 300 times 150. So multiply those out, that's meters squared. Whatever, 445 with 3 zeros, I think. Probably double check
Yes.
that. There you
I
go.
just did. Yeah. Okay. Okay, that's a good trick. I'm so bad at
Yes.
word problems, so that really helps.
Yeah, every student struggles. So like I am trying my best to give you the shortcuts here. I mean, you're not going to ever be asked to do calculus and whatever you're doing beyond school.
Yeah.
Okay, we're gonna 9. I'm skipping because it's gonna just we could do it next time, or you can just
Yeah, that's fine. Mhm.
but so Newton's method, incredibly important. It's what allowed the first astronauts to get to the moon, believe it or not.
Cool.
It's a really powerful approach. You need to know the recipe to do it. So x2 is equal to x1. Well, actually, I need to back up here and see what they're doing. So x1 is equal to x0 minus f of x0 over f prime of x0. And you might be like, oh my goodness, what is this? What does all this mean? Well, when you put the number in, it'll make sense. So x1 is equal to 0 minus f of 0 over f prime of 0.
Okay.
So do you have a function?
Yes.
your f of x, which they don't really give you very clearly here. It's x cubed plus 4x minus 5.
Okay.
So you got to put 0 in for that. So put 0 into to that function for me, please.
It'd be -5.
Okay, so that's our numerator. And then you need the derivative. So what is the derivative of this function?
3x squared plus 4.
3x squared plus 4. So now you've got to put 0 in for that. What does that become?
4.
4. So this becomes 5 over 4. Okay, that's great, but we don't want it. We want x2. So if you follow the pattern here, this you will have to remember. So x2 is equal to x1 minus f of x1 over f prime of x1. So your
Okay.
x1 is that 1.25. So that goes into the equation here. Like that.
Okay. And then just plug it in. Wait, do I take the derivative again, like the second
Oh,
derivative?
nope,
No?
nope. So you go back to, you go back to the original. So this is 1.25 cubed minus or plus 4 times 1.25 minus 5. And then like you said, 3 times 1.25 squared plus 4 times 1.2, or just plus 4, sorry.
Okay. The top I got in fraction form, it's 125 over 64.
You, how you want to represent it, you are rounding to 4 decimal places, so
Oh,
I
okay.
would, the whole answer. So you are going to want to, yeah,
1.953125. Said round to 4.
the final answer when you're
Oh,
finally
okay.
done. So intermediate answers, you want to go to like double the decimal places typically is a
Mhm.
good strategy. There's no there's no like perfect answer to tell you
Mhm.
that.
Over 8.6875. Oops. Mm. Mhm. Okay. I got, if it wants me to round to 4 decimal places, I got 1.0252.
All right, correct. We good.
And then since you showed me how to do that, I can do 12 on my own since there is only like 2 minutes left.
Yeah, I'll make a quick comment here on 12 that you really want to move everything to one side. So it's natural log of x
Okay.
plus x minus 5 is your f of x.
Okay.
And then your f prime of x equals 1 over x plus 1. Let me, because there's, a million calculators on the internet, let me
Mhm.
give you the results here in case you want to check your answer later on.
Okay.
And we're starting out at 8 execute. All right. So this table might not make much sense to you, but the answer is is this one over here. So, but you know, I'd recommend trying it. You're more likely to get the other one on the test. You will get a Newton's method on your test for sure.
Oh yeah, they gave me everything on this last
Yeah.
test, like one of everything.
Yeah. The terrible strategy, say, oh, I hope it's not on the test.
Yeah,
That's
no,
just the
all of it
terrible
was.
strategy. Yeah, it's